Welcome to Spring LIB.
Hi, let us imagine a disk which is moving on a plane and we are given certain velocity components at certain points. Let's call them A, B, and C. And we are not given all the velocity components, but we are given some velocity components. So for example, at B, we are given that the x component of velocity is minus 7.4. Now you may notice that the way I have drawn the vector is not exactly having a negative x component, but this is just for illustration purpose, and this is just to show you that you can assume any direction, but if mathematics gives you the correct answer with positive and negative components, the physics always works out in the end. So we'll just assume certain directions for all these points consistent with our omega. So let us assume omega to be, if you assumed velocities arrows on ABC as shown, then you take your right hand, curl it around these vectors. You'll find that your omega is pointing inwards. However, you can see that this is not correct because the x component of velocity at VB is given to be negative. But we'll see that this all works out in the end. We'll see that. So VB is this, and then we don't know the y component. So this is some VBY. At VC, similarly, we know the x component. This is minus 1.4. These are all in meters per second, so I'm not writing down the units. So we'll assume all of them to be meters per second. So this is velocity at point C, and at point A, this time we don't know the x component, but we know the y component. Now, to solve any of these problems, the first step is to break the motion into translation plus rotation. So this is our disk, and we'll assume some translational velocity Vt, which is going to be same for all points. This is one of the known properties of translational velocity. This is the definition of a rigid body. So at A, B, and C, we have the same translational velocities. And if our omega is in this direction, going into the page, then if you take cross product of omega with different r vectors at A, B, and C, you will figure out that omega cross r is going to point like this. So this is omega cross r, which will be omega r and sine 90 because this is perpendicular to the radius vector joining the points A, B, and C. Okay, so now we have rotational and translational components, and the sum of these two velocities is going to give you net velocity, net V. Okay, so let us break down the components and equate them, but let's do this with the known numbers. So for VA, so x is unknown, but y is given to be minus 7 meters per second. So let us write equation for VA y. So for VA y, this is minus 7. And if we look at A, we will have component of Vt along y. So it's omega r plus Vt y. So this is equation 1. And then we know VBX. So for VBX, the equation will be minus 7.4. This is given. And then if we look at the vector diagram at point B, then Vt is going to contribute towards x. So Vtx plus omega r, this will be minus 7.4. This is equation 2. And at point C, we see that Vtx is the only component which will contribute, and Vty is just going to be perpendicular and along omega r. So this tells us that Vcx, which is minus 1.4, is actually Vtx. So now we know the value of Vtx from equation 3. So once we know that, we can replace this in equation 2. This will imply that omega r is minus 7.4 plus 1.4, which is minus 6 meters per second, since everything is in meters per second. So this is omega r, and the radius is 600 millimeters. So we can figure out omega. So omega is going to be minus 6 meters per second, and radius is 600 millimeter, which will be 0.6 meters. So this will become minus 10 radians per second. So now notice that the omega we have got is negative. So the direction of omega, it's negative minus 10 radian per second, and then we have taken it to be on negative z. So actual omega is 10 radian per second in positive direction. So if you look back at our diagram, omega is going to point up. So wheel is going to rotate in this direction actually. So if the wheel is rotating in this direction, all the velocities will flip. You can imagine that, and then all these negative components of velocities actually are correct because all these arrows will flip, because now you have figured out the correct omega. So that's why if you are consistent in your sign convention and follow the mathematics correctly, you actually end up with the correct physical picture. But anyways, this was for demonstration purposes. So we have figured out our omega is 10 radians per second positive z direction. What is our velocity of b? So for velocity of b, we need the y component of b, and y component of b is vt of y. So we need vt of y. So this is vt of y. And then from equation 1, we know that minus 7 equals omega r plus vt of y. So vt of y will be minus 7 minus omega r, and omega r was calculated to be minus 6 here. So we just plug this back in because we are using our older sign convention for everything. So minus omega r will become plus. So it's plus 6. So the answer will be minus 1 meters per second. So our final velocity of by component is minus 1 meters per second. And the overall velocity of b can be now written as minus 7.4 meters per second x, then minus 1 meters per second in y. So this is how you can find out velocities of different points and omega by breaking everything into translation plus rotation. So this is the basic principle to solve all such kind of problems. Thank you.